Now I'm going to explain the different processes. Like when you are studying about thermodynamic process, as I explained earlier, thermodynamic process is a process. It is a process that occurs when there is a change in any of the thermodynamic parameters or coordinates. So here there will be a thermodynamic process if and only if there is a change in either of these thermodynamic coordinates. So this is a process that occurs. So there is a thermodynamic process. We call that there is a thermodynamic process if and only if there is a change in temperature, pressure, or volume that takes place, that occurs when there is a change in any of the thermodynamic coordinates. When there is a change in volume, temperature, or pressure. And there are, like here you can see here, when just here you can see that this boy is trying to push, like he's trying to push this side. He's trying to push the liquid, like just compressing the liquid from the left side. So as you can see here, when he's trying to push to the right, the temperature will rise. See now, let me show you. Wait. Look, when he's trying to push, look at this thermometer. The thermometer will start to rise now. Look, this man tries to push. He's trying to push this side to the right. Means he is trying to minimize the volume. There will be change in volume. So when there is change in volume, we will see here, we are going to see a change in temperature. The temperature will rise. The temperature is now rising. See, this is because he is trying to push, means he is just making the particles to move faster. They will start to collide. They will continuously collide with the walls of the container. So when they collide with the walls of the container, they start to move fastly. See, as you can, their speed is increasing. As the volume decreases, look here, this is very important. When this side of the container is pushed to the right, the motion of the particles is increasing. They are starting to move quicker, fastly. So as they start to move fastly, the temperature is rising. But here what happens is there is no any external factor or netting energy is added to the system. Okay? So here energy is neither added to the system nor is given out from the system. So only what he is doing is he is only changing the volume, or he is trying to push this to the right. So when he tries to push to the right, the particles start to move quicker. So as the particles are moving, the kinetic energy increases. So as the kinetic energy increases, definitely the temperature will also increase, because temperature is defined as a measure of average kinetic energy of the particles. So as the particles collide quickly, as their kinetic energy increases, the temperature starts to rise. Look here, without giving any external heat to the system, the temperature, we are changing the temperature. We are making the temperature to rise or to decrease by changing the size of the container. So here, don't forget that this kind of experiment is called, or this kind of increasing the temperature is called adiabatic factor, adiabatically. So adiabatic process is a process during which no energy is transferred to or from the system as heat. Here, no energy is added to the system or transferred from the system as a form of heat, but there is a change in temperature. So this process is called adiabatic process. So this is a thermodynamic process during which no energy is transferred to or from the system as a heat. By the way, if you want to cool down the system, if you want to decrease the temperature, just go back, move to this side. So increase the volume. So when they just increase, the motion of the particles slows down. So as the motion of the particles slows down, the temperature starts to just move down. The temperature starts to decline. The temperature decreases. So this experiment is called, or this process is called adiabatic process. A process where it's a thermodynamic process where or during which no energy is added or transferred to the system or from the system as a form of heat. So this is called adiabatic process. But here we are just changing, we are getting different, we are changing the temperature of the system. The second type of thermodynamic process is called isothermal process. Iso means, as you can see from the name, is the same. So isothermal process is a thermodynamic process that takes place at the same temperature. Iso means the same, thermal is temperature. So isothermal process is a process that takes place at a constant temperature, at the same temperature. Constant. Iso means constant or invariant or the same. So isothermal process is a thermodynamic process that takes place at a constant temperature. The temperature doesn't change. So isothermal process is a process or a thermodynamic process that takes place at constant temperature and in which the internal energy of the system remains constant. But also here in isothermal process, the internal energy of the system remains constant. This is very important concept that you have to know. So because internal energy of a system is directly proportional with the temperature. The internal energy remains constant because internal energy of a system is directly proportional with the temperature, because as the temperature rises, when the temperature increases, the motion of the particles also increase, because temperature is a measure of average kinetic energy of the particles. So as the temperature increases, the kinetic energy of the particles increase. The particles start to move randomly everywhere. So as the energy increases, we mean that its internal energy is also increasing. So here what you have to is the internal energy of a system is directly proportional with the temperature. It is proportional, the internal energy, U is the internal energy, it is directly proportional with the temperature of the system. As the temperature rises, as the temperature of the system rises, the internal energy also increases. So internal energy increases as the temperature increases. This is very important. So the internal energy of the system increases as the temperature of the system increases, and it decreases when the temperature decreases. So internal energy of a system depends upon its temperature. But here in an isothermal process, because the temperature is constant, the temperature doesn't change, the temperature remains the same. That means the internal energy of the system also remains constant. It doesn't change. So isothermal process is a thermodynamic process that takes place at a constant temperature and in which the internal energy of the system remains unchanged. It remains constant means it remains unchanged because the internal energy of a system is proportional with the temperature of the system. So this is the second second thermodynamic process that takes place at a constant temperature. And the third thermodynamic process is called isovolumetric process. Isovolumetric process is a thermodynamic process. Isovolumetric process is a thermodynamic process that takes place at a constant volume. The volume doesn't change. The change in volume is zero. We don't have change in volume. So the volume doesn't change. So isovolumetric process is a process that takes place at a constant volume. So if the volume doesn't change, we know that if the volume of the system doesn't change, no work is done on or by the system. That's very important, because we know that work is defined as the work done on or by the system is defined as the pressure multiplied by the volume change. But in isovolumetric process, the volume of the system remains the same, or the volume doesn't change. That the volume remains constant, which is V initial is the same as the initial volume is now. Volume doesn't change. When I said, I will write it here. The volume remains constant means initial volume is equal to the final volume, so that the change in volume, which is given by the difference of final volume and initial volume, is equal to 0. We don't have change in volume. The volume is neither increasing nor decreasing. The volume remains the same. So if the volume remains constant, or if the change in volume is 0, no work is done on or all by the system. So here, since the change in volume is 0, since we don't have change in volume, this the work done will be 0. So this means no work is done. So here, this is very important. In isovolumetric process, no work is done on or by the system. So no work is done on or by the system. So isovolumetric process is a thermodynamic process that takes place at a constant volume, so that no work is done on or by the system. The work done by the system or the work done on the system is 0, because the volume is not changing. And the fourth process, thermodynamic process, is a cyclic process. A cyclic process is a process, here I'll write it here. The fourth type of thermodynamic process is a cyclic process. The fourth type of thermodynamic process is a cyclic process. This is a thermodynamic process in which a system returns. This is a thermodynamic process. A thermodynamic process in which a system returns to its returns to the same conditions under which it started. So a thermodynamic process in which a system returns to its original condition, so returns the same condition under which it started, is called a cyclic process. So a cyclic process is a process in which a system returns to the same condition under which it started. So that this process is called a cyclic type of process. So here the four types of, to summarize, the four common thermodynamic processes are now the four types of thermodynamic processes are isovolumetric process, isothermal process, adiabatic process, and cyclic process. These are the four common thermodynamic processes. So isovolumetric process is a thermodynamic process that takes place at a constant volume, so that no work is done on or by the system. The second is isovolumetric isothermal process. That is a thermodynamic process that takes place at a constant temperature. So the temperature is constant. That means the internal energy of the system remains unchanged. It remains constant because internal energy of a system is directly proportional with the temperature. As the temperature increases, the internal energy also increases. As the temperature drops, internal energy decreases. The third type of process is called adiabatic process. This is a thermodynamic process during which no energy is transferred to or from the system as a form of heat. So heat is energy is not transferred to the system, or energy is not released from the system as a form of heat. The fourth type of thermodynamic process is cyclic process. This is a thermodynamic process in which a system returns to the same condition under which it started. So these are the four common types of thermodynamic processes.